Hey everyone, welcome back to another video here on Try Hack Me. I'm John, and today we're going to take a look at the Linux Fundamentals Part 2 room. Continue your Learning Linux journey with Part 2. You will be learning how to log into a Linux machine using SSH, how to advance your commands, and some file system interaction. That being said, let's go ahead and dive right into Task 1, Introduction. Welcome to the second part of the reworked Linux Fundamentals series. We'll be applying our knowledge from the first installment of this series, so I highly recommend you completing that room before proceeding further. In part 2, we'll be ditching the in-browser functionality and help you get started in what is a fundamental skill in being able to log in to and control the terminals of remote machines. Not only this, but the room will also have you unlocking the potential of your first few commands by introducing you to using flags and arguments, advancing your knowledge of the file system to perform some more useful commands such as copying and moving files, introducing you to the access mechanisms in place to keep files and folders secure, and how to identify the things that our current user has access to, and then finally running your first few scripts and executables. Let's proceed. We'll go ahead and mark this as completed, close that, and then move into Task 2, accessing your Linux machine using SSH. The in-browser functionality was used in Linux Fundamentals Part 1 to get you directly connected to your first ever Linux machine without any hassle. In fact, the in-browser functionality uses the exact same protocol that we are going to be using today. The protocol is called Secure Shell, or SSH for short, and is the common means of connecting to and interacting with the command line of a remote Linux machine. We will be deploying two machines in this room: your Linux machine and the Try Hack Me attack box. What is SSH and how does it work? Secure Shell, or SSH, simply is a protocol between devices in an encrypted form. Using cryptography, any input we send in a human-readable format is encrypted for traveling over a network, where it is then unencrypted once it reaches the remote machine, such as in the diagram below. And here we can see we have our computer, the internet, which we're using to connect over, and then the Linux server that is remote or not in the same room as us. You can learn about the various types of encryption on a Try Hack Me room. And one thing to note, you can use this with machines on your own network. This is just a nice way that you can connect to things from one computer and have everything, maybe your workstation, and you want to connect into a server that you're running, or things like that. But for now, we only need to understand that SSH allows us to remotely execute commands on another device, and remotely, any data sent between the devices is encrypted when it is sent over a network such as the internet. Deploying your Linux machine. Press the green Start Machine button at the top right of this task, and then scroll to the top of the page to see the deployment info like so. Let's go ahead and do that now. We'll start the machine, and we can see that we are given a couple pieces of information along with some commands. So the first thing that we have up here is the title. That's not very important. Don't worry about that for now. We have the IP address, which is what we're going to use to target the machine. This gives us sort of the street address that it's at, so we can send it mail. And then we have the expiration time. By default, all machines on Try Hack Me currently have a 2-hour lifespan. So when you start them up, in 2 hours from that time, they will automatically turn themselves off. In this case, we can see that we also have another couple buttons. We have add 1 hour, so if this expiration time falls below 1 hour, we can add another hour to extend it in case we're taking a long time with the current machine or we want to continue working on it. And then we also have terminate if we want to turn this off. Note, this IP address is hidden for the first 60 seconds, I believe, and that is done because the machine's starting. It might be ready to go, but we want to give services time to start up, hence why it is hidden in that case. Let's go ahead and scroll down. We've already gone over that information. And then we also want to deploy the Try Hack Me attack box. Looking at the top of the page, press the Start Attack Box button to deploy the Try Hack Me attack box that we will be interacting with. We can scroll back up. We see this blue button right here. Go and click on that. And our screen is going to be divided here in just a moment. Now, this is our Kali machine that is already on the Try Hack Me network. Now, one thing to note, if you are a free user, this will not have access to the internet. It can just talk to these other machines that we have spun up. Additionally, it's worth noting that as a free user, you have a maximum of 1 hour of usage of this per day. So once you start it, it needs to stay. If you want to continue using it, don't turn it off, and you have a full hour of that time. If you are a subscriber, you do have unlimited usage of this machine, and it does have access to the internet. Let's go ahead and continue down while we let these machines boot. Alright, using SSH to log into your Linux machine. The syntax to use SSH is very simple. We only need to provide two things: the IP address of the remote machine, and then correct credentials to a valid account to log in with on the remote machine. For this room, we will be logging in as TryHackMe, whose password is TryHackMe, not a strong password by the way, without the quotation marks. Let's use the IP address of the machine displayed in the card at the top of the room as the IP address, and this user to construct a command to log into the remote machine using SSH. The command to do so is SSH, and then the username of the account, and then @ IP address of the machine. And here we can see a breakdown of that command right here. Now, one thing to note, we do need to open up a terminal on the attack box once it starts in order to be able to type this command. That being said, we can see a screenshot of what that would look like down here, and we can give it just a moment for the machine to start. I'm going to go ahead and pause the recording now, and when we're back, we'll go ahead and log in. Alright, and we're back. The machine just finished booting. Now we have a little warning as well as some instructions. I'm going to click past this for now, and you can do the same. You just click into the terminal and then press enter to close that. Now we want to go ahead and open up our own terminal, and we can do that by double clicking the terminal application there. And now we can log in. Let's go ahead and scroll back up to get the target IP address of the machine that we're going to connect to. And we will go ahead and connect to it using the command SSH 10, actually try hack me at 10.10.137.96. And then we'll type in yes, and then our password for that user is tryhackme, all lowercase. And there we go, I managed to type it in correctly. I went ahead and cleared the screen with Control and L, so I held down the Control key and then hit L. That just cleans up what loads right away, and then we can go ahead and move into the next task. We'll go ahead and mark this as completed and move into Task 3, Introduction to Flags and Switches. A majority of commands allow for arguments to be provided. These arguments are identified by a hyphen and a certain keyword known as flags or switches. We'll later discuss how we can identify what commands allow for arguments to be provided and understanding what these do exactly. When using a command, unless otherwise specified, it will perform its default behavior. For example, ls lists the contents of the working directory. However, hidden files are not shown. We can use flags and switches to extend the behavior of commands. Using our ls example, ls informs us that there is only one folder named folder1 as highlighted in the screenshot below. Note that the contents in the screenshot below are only examples and are not those of the instance you deploy in the room. So this is just an example, it won't be the case over here. However, after using the -a or -a argument, short for --all, we now suddenly have an output with a few more files and folders, such as .hidden folder, and then we can see a couple other ones here. Files and folders with a period at the beginning are hidden files. A lot of times this is just system things or more configuration files that you don't necessarily need to see otherwise, and that's why these are hidden by default. Commands that accept these will also have a --help option. Sometimes this is -h, however, not every command has a -h that specifies help. However, most commands that we can use have this --help option. This option will list the possible options that the command accepts, provide a brief description, and an example of how to use it. This option is, in fact, a formatted output of what is called the man page, short for manual, which contains documentation for Linux commands and applications. The manual page, pages are a great source of information for both system commands and applications available on both a Linux machine, which is accessible on the machine itself, and online. So here we can see that we have the online version of the man page. You can click into that and explore around. It can be very helpful for searching if you're not that comfortable with the command line yet. And this will also come up in Google results along with Stack Overflow. Both of those are a pretty good resource. To access this documentation, we can use the man command and then provide the command we want to read the documentation for. Using our ls example, we would use man space ls to view the manual pages for ls like so. And we can see an example up here. Explore the manual page of the ls command. Let's go ahead and do man ls, and there we go. Mark that as complete. And then what directional key will be used to navigate down the manual page? That is going to be the down arrow. Fairly self-explanatory. And then what flag will be used to display the output in a human readable format? Now we can scroll down and eventually we will find a -h command, or -h flag rather, that allows us to specify that we want our output from ls to be in human readable format. And there we go. Let's move into task 4, file system interaction continued. Now we can go ahead and close the man page by pressing Q, and we can see that's down here as well. There we go. We covered some of the most fundamental commands when interacting with the file system on the Linux machine. For example, we covered how to list and find the contents of folders using ls and find, and navigating the file system using cd. In this task, we're going to learn some more commands for interacting with the file system to allow us to create files and folders, move files and folders, and delete files and folders. And you can see that you have the list here. I recommend adding that to your notes, and then we have a pro tip at the bottom. Similarly to using cat, we can provide full file paths, i.e. directory 1, directory 2, note for all these commands. So you can provide full paths for these as well as relative paths, which don't worry about that too much right now. This is just the full proper path to it on the system if you want to specify that. Creating files and folders with touch and make dir. Creating files and folders on Linux is a simple process. First, we'll cover creating a file. The touch command takes exactly one argument, the name we want to give the file we create. For example, we can create the file note by using touch and then space note, again where note is the name of the file. It's worth noting that touch simply creates a blank file. You wouldn't need to use commands like echo or text editors, or you would need to rather use commands like echo or text editors such as nano to add content to the blank file. And here we can see that down here after that has been created with touch. This is a similar process for making a folder, which just involves using the make dir command, or mkdir command, and providing the name that we want to assign that directory. For example, creating the directory my directory, we can do that with make dir and then the name of the directory right here, my directory, and we can see that's done in the example below. Removing files and folders with rm. Rm, short for remove, is extraordinary out of the commands that we've covered so far. You can simply remove files by using rm. However, you need to provide the -R switch alongside the name of the directory you wish to remove, in case you want to remove a directory. So this is a recursive option, I believe, which removes the directory and all of its contents, as otherwise rm will say, hold on, I can't do this. So here we can see that we've removed note in this example, and that file is no longer here. However, to remove a directory, you can see it doesn't work without providing -R, but if we provide -R as a switch, it will remove it. Copying and moving files and folders with CP and MV. Copying and moving files is an important functionality on a Linux machine. Starting with CP, short for copy, this command takes two arguments: the name of the existing file and the name we wish to assign to the new file when copying. CP copies the entire contents of the existing file into the new file. In the screenshot below, we are copying note to note 2, and we can see that right here. Moving a file takes two arguments, just like the CP command. However, rather than copying and or creating a new file, MV, short for move, will merge or modify the second file that we provided as an argument. Not only can you use MV to move a file to a new folder, but you can also use MV to rename a file or folder. And you can just move it to the same location that it's already in if you want to just rename it. For example, in the screenshot below, we are renaming the file note2 to be named note3, and we can see that right here. Note 3 will now have the contents of Note 2 because it was that file at one point. Determining file type. What is often misleading and often catches people out is making presumptions from files as to what their purpose or contents may be. This is something that's very common in CTFs. And this next command, especially for CTFs and in a situation where you don't have a file extension, is going to be very handy in those cases. Files usually have what's known as an extension to make this easier. For example, text files usually have an extension of .txt, but this is not necessary. Windows will require this for most files, and that's how it knows what program to open it with by default, and I believe OS X has a similar functionality with it. However, Linux doesn't really care. We don't have to have file extensions. It's recommended, as it is best practice, however, it's not necessary. So far, the files we have used in our examples haven't had an extension. Without knowing the context of why the file is there, we don't really know its purpose. Enter the file command. This command takes one argument. For example, we'll use file to confirm whether or not the note file in our examples is indeed a text file, like so. And you can see that we've done that with file, and then the file that we want to examine, and sure enough, it is an ASCII text file. How would you create the file named new note? We can do that with the command touch, and then the name of the file we want to create. On the deployable machine, what is the file type of unknown1 in tryhackme's home directory? So we can do ls, and we have unknown1. We'll do file unknown, and I can type part of that and hit tab to have it autocomplete. And there we go. We can see that it is an ASCII text file. There we go. How will we move the file my file into the directory my folder? We can do that with the mv command, and then my file, and then my folder. And there we go. What are the contents of this file? So let's see. We want to cat my file. There we go. And we can see that we have our flag thm file system. And there we go. Continue to apply your knowledge and practice the commands from this task. I do recommend playing around just a little bit so that you can become a little bit more familiar with these commands. Once you're ready, go ahead and move on to Task 5, Permissions 101. As you would have already found out by now, certain users cannot access certain files or folders. We've previously explored some commands that can be used to determine what access we have and where it leads. In our previous task, we learned how to extend the use of commands through flags and switches. Take, for example, the ls command, which lists the contents of the current directory. When using the -l or -l switch, we can see 10 columns such as in the screenshot below. However, we're only interested in the first 3 columns. And you can see that right here, where we have the properties, and D right here, it's a little bit covered up by the outline. That specifies where there's a directory, and a dash in that first bit here specifies where there's a file. Then we have the file owner, and then we have the group that's an owner. One thing to note, on Linux, whenever you create a new user, there is a group that's created that's named the same as that user. Hence why we have a user CMNATIC, and then we have a group CMNATIC. Although intimidating, these 3 columns are very important in determining certain characteristics of a file or folder and whether or not we have access to it. A file or folder can have a couple of characteristics that determine both what it is that, and who can do with it as. So in other words, it determines the owner and what we can actually do with it, if we can read, write, or execute the file. We can see that broken out down here below. The diagram below is a great representation of how these permissions can be translated, and we can see that we have these 4 different areas that we're looking at, and again, that's mirrored up here. So breaking this down, again, I mentioned this previously, that this first bit here specifies if it is a directory or just a regular file. Since we have a dash here, we know we're working with a file. Next, we have RWX. This is short for read, write, and execute. This first group here is the permissions that are available for the file's owner. Next, we have those in the same group as the file owner, and last but not least, everyone else on the system. And we can see that in this case, since RWX is available or printed at each one in every single space here, everyone can read, write, and execute this file in question. However, in this case, if we scroll up just a little bit more, we can see that there are examples where there are dashes instead of those letters. Where there is a dash, that permission is not available for those in that user group. So if we take a look at this example right here, we have that the user who owns this can read and write to it but not execute it, and everyone else can only read it. There's no write or execute set to be available. Let's use the cmnatic.pem file in our initial screenshot at the top of this task. And you can walk through this as well. So here we can see that we have the cmnatic.pem where the owner can read and write to this file, but no one else can do anything. And the owner cannot execute that. Briefly, the differences between users and groups. We briefly explored this in Linux Fundamentals Part 1, namely the differences between a regular user and a system user. The great thing about Linux is that file permissions, or permissions rather, can be very, very granular, that whilst a user technically owns a file if the permissions have been set, then a group of users can also have either the same or a different set of permissions to the exact same file without affecting the file owner itself. Let's put this into a real-world context. The system user that runs a web server must have permissions to read and write files for an effective web application. However, companies such as web hosting companies will have to want to allow their customers to upload their files for their website without being the web server system user, compromising the security of every other user. So essentially, when you are interacting with a web system, or a website rather, such as TryHackMe, and you can upload something like a profile picture, you are running that actual process is running as a low privilege user that can't just overwrite files on the website. That wouldn't be very secure, because then we could upload whatever website we want on anyone's website. And that does happen. That is a common security issue. Okay, uncommon security issue, but it does happen. Switching between users. Switching between users on a Linux install is easy works thanks to the su command, short for substitute user. I like to remember this as switch user. It's not technically correct. Substitute user is the way that this is abbreviated from. Unless you are the root user or using root permissions through sudo, then you are required to know two things to facilitate this transition of user accounts. The user we wish to switch to, and then that user's password. You need to know that user's password in order to change to be them, unless you are just super user. The su command takes a couple of switches that may be of relevance to you. For example, executing a command once you log in, or specifying a specific shell to use. You might have a specific shell you really want to use, such as bash or zsh. That's up to you, and that's outside of the scope of this actual room. Don't worry too much about this, just something to have as a general piece of knowledge. I encourage you to read the man page for SU to find out more. However, I will cover the -L or --login switch. Simply by providing the -L switch to SU, we start a shell that is much more similar to the actual user logging into the system. So it simulates an actual login. The thing with this is we have that user's environment variables actually populate, which can be very useful, especially if we are in a programming environment where we need to have access to, say for example, we're assuming the web user that runs the website. We want to be able to access that user's environment variables, and we want them actually loaded into our current session. So makes a big difference. If you have a development background, that will make a little bit more sense. For now, don't worry too much about it. Just if something's not working, you probably need to use this -L switch. For example, when using su to switch to user 2, our new session drops us into our previous user's home directory. So we can see that using the login here, it is moving us to that home directory because we're actually simulating that login and we're switching what directory we're in. We're now, after using the -L, our new session has dropped us into the home directory of user automatically. And you can see if we don't use it, we just stay in our old home directory, where we don't have permissions for anything. Not very convenient. On the deployable machine, who is the owner of important? So we can go ahead and do ls-l, and we can see that important is owned by user 2. There we go. What would the command be to switch to user 2? We saw that before in our examples with su and then user 2. Now switch to this user 2 using the password user 2. We can use su, and then I'm going to use the -l to switch to that user's home directory. Actually, we don't want that in this case. su user 2, and then user 2. And then we want to be able to read important. Let's go ahead and cat important. And there we go. Now, one thing to note, we could read this beforehand because the root permissions are enabled. However, we're reading this as the actual user now. And there we go. We have our flag, thm su underscore user 2. And there we go. Let's move into task 6, common directories. First, we have /etc, or etc. This root directory is one of the most important root directories on your system. The etc folder, short for etc, and etc is the common way to pronounce this. It's pretty fast, and it's just commonplace within IT to call it that way or pronounce it that way, is a commonplace location to store system files that are used by your operating system. For example, the sudoers file, which allows, that specifies who can run things with root permissions. Don't worry about this too much. It's outside of the scope of this room. Just know that it exists and something you'll eventually want to be familiar with. For example, the sudoers file highlighted in the screenshot below, which we can see right here, contains a list of the users and groups that have permission to run sudo or a set of commands as the root user. Also highlighted below are the passwd and shadow files. So we can see those right here. Those two files are special for Linux as they show how your system stores the passwords for each user in encrypted formatting called SHA-512. Don't worry too much about this. These are very powerful files. If you are in a system you don't own and you have root permissions, or if you can somehow access especially the shadow file right there, you can do very bad things. Don't worry about it too much right now. Just know that these files should be protected. You can read this passwd as any user, but you should not be able to read shadow. /var. The /var directory, with var being short for variable data, is one of the main root folders found on a Linux install. This folder stores data that is frequently accessed or written by services or applications running on the system. For example, log files from running services and applications are written here. So for example, specifically in the var log file, or in that directory rather, or other data that is not necessarily associated with a specific user. For example, databases and the like. Then we have /root. Unlike the /home directory, the root folder is actually the home for the root system user. This is just their home directory. And again, I preface this a little bit in Linux Fundamentals Part 1. This is just where your documents and everything that your user specifically owns will live. Pictures, your desktop, things like that. There isn't anything more to this folder other than just understanding that this is the home directory for the root user. But it is worth a mention, as the logical presumption is that this user would have their data in the directory, in a directory such as home/root, which is not the case. Root does have its own directory, and this is consistent off of, I believe, every single Linux distribution. There may be some bizarre Linux distribution that doesn't have this as a default rule, however, I've never come across it. /temp, or tmp. This is a unique root directory found on a Linux install, short for temporary. The temp directory is volatile and is used to store data that is only needed to be accessed once or twice. Now, one thing to note, don't put anything here you care about, especially don't take notes into this directory. It's something that as soon as the computer is restarted, which is referenced right here, this is cleaned out and everything in there is just wiped. I've made the mistake of storing things in this folder that I cared about. Don't make the same mistake. Don't store anything in there that you don't need very temporarily. What's useful for us in pen testing is that any user can write to this folder by default, meaning once we have access to a machine, it serves as a great place to store things like our enumeration scripts. You can store your shell here. Sometimes this won't be the case, but again, that's outside of the scope of the room. Generally speaking, /temp is going to be your friend just to check things into, as you can, by default, write to it. README, we've gone ahead and completed that. what is the directory path that we would expect logs to be stored in? That is var log. What root directory is similar to how RAM on a computer works? This is cleared on restart, and then that's the /temp directory. Name the home directory of the root user, and that is going to be /root. And then now apply your learning and navigate through these directories on the deployed Linux machine. I'm not going to do that in this case. I will let you practice this on your own. Once you're comfortable with this, move on to task 7, conclusions and summaries. And we'll do that right now. Nice work. This room was quite theory heavy and covered quite a range of the fundamentals in getting you familiar with Linux. To quickly recap, this room taught you how to connect to a Linux machine remotely using SSH, advancing your use of commands by providing flags, switches, and where you can go to learn about these for each command via the man pages, some more commands that you'll frequently be using to interact with the file system and its contents, a brief introduction to file permissions and switching users, and then a summary paragraph of the important root directories on an Ubuntu install and how we may be able to use the data stored within these. I encourage you to go through this room again once or twice to gain some familiarity with the concepts. After all, practice makes perfect. And I highly, highly recommend taking notes over this. If you don't take notes regularly when you are covering things like this, believe me, it will help you retain this knowledge a little bit better. Even if it's just copying out those tables that we have with the commands, it will help. We'll go ahead and mark that as completed and move into Task 8, Linux Fundamentals Part 3. Visit Part 3 of the Linux Fundamentals series here. So first we want to go ahead and terminate the machine from Task 2. I will scroll up and we can press the red Terminate button. Don't terminate your attack machine. We do need that for moving into Part 3, so there's no point in closing it unless you're done on TryHackMe for the time being. And then you can go ahead and close that down. We'll go ahead and mark that as completed, and then you can go ahead and join the Linux Fundamentals room via that link. I will see you there in the next video, but until then, happy hacking!